Welcome to Lesson 1.1 of the Certified AI Fundamentals program. Congratulations on starting your AI certification journey. In this first lesson, we'll explore the foundations of artificial intelligence. You'll get a clear practical understanding of AI at a high level before we dive into specific subfields in later lessons. By the end of this session, you'll feel confident in discussing AI's role and importance, whether in an interview, in the workplace, or on the exam. And now here are the objectives for this lesson. By the end, you'll be able to define artificial intelligence and its purpose, differentiate between AI, machine learning, and deep learning, explain what generative AI is and how it relates to deep learning, recognize major milestones in AI's evolution, and identify key strengths and limits of AI. So let's begin. So, what is artificial intelligence? Artificial intelligence is the broad science of creating systems that can perform tasks requiring human like intelligence, such as reasoning, problem solving, perception, or understanding language. Machine learning is one approach within AI where systems learn patterns from data and use them to make predictions or decisions. Deep learning is a subset of machine learning that uses multi-layer neural networks to capture complex patterns, powering things like image and speech recognition. Generative AI refers to models that create new content, like text, images, or code, and most modern generative AI relies on deep learning. It's also important to distinguish between the different levels of AI. First, we have narrow AI, sometimes called weak AI. These are today's real-world systems, designed for specific tasks like recognizing images, detecting fraud, or powering chatbots. They can be extremely effective, but only within one domain. In fact, every AI system in use today is narrow AI. The next level is artificial general intelligence, or AGI. This is a hypothetical form of AI with human level intelligence across many domains. To qualify as AGI, a system would need the ability to reason, learn, adapt, transfer knowledge, and plan across diverse situations, much like a person can. It's important to note, though, that AGI does not exist today. Beyond that is superintelligence, an even more speculative concept. This refers to systems that could surpass human intelligence in nearly every respect, excelling at reasoning, creativity, scientific discovery, strategic planning, and even redesigning themselves. But it's also important to note that, like AGI, superintelligence remains theoretical. It does not exist. For the purposes of this course, remember, the AI we use and study today is entirely narrow AI. And now here's a helpful way to visualize the relationship between different types of AI in this AI Venn diagram. Think of artificial intelligence as the broadest circle, the entire field of creating systems that act intelligently. Inside that, we have machine learning, methods that allow systems to learn patterns directly from data rather than being hand programmed. Nested further is deep learning, which uses neural networks with many layers to capture complex patterns and solve problems like image or speech recognition. Finally, within deep learning, we find generative AI. These models don't just recognize or classify, they actually create new content like text, images, or code. Not every deep learning model is generative, but nearly all the breakthroughs in generative AI today come from deep learning. So, examples help bring these distinctions to life. AI without machine learning includes early systems that simply followed rules rather than learning from data. For instance, the classic Eliza chatbot from the 1960s mimicked conversation by matching keywords to scripted replies. Or think about the ghosts in Pac Man. They weren't learning, they were just following simple program rules, like chase when close or wander otherwise. Machine learning examples are more familiar today. A spam filter trains on labeled emails to detect junk. Banks use machine learning for fraud detection and credit risk scoring. And recommendation engines, like those on Netflix or Amazon, learn from past choices to suggest what you might want next. Deep learning powers many of today's major breakthroughs. Systems for image recognition, speech recognition, and even large language models are all based on deep neural networks. Generative AI goes a step further. These models don't just classify or recognize, they create. Examples include chatbots like ChatGPT, text to image tools like DALL-E, coding assistants like Copilot, and even AI systems that generate music. Together, these examples show the progression from rule-based AI to learning systems to deep learning and now to generative models that can create entirely new content. So now let's take a look at a timeline of some of the most important milestones in the evolution of artificial intelligence. So in 1950, there was Alan Turing and the imitation game. Alan Turing, often called the father of computer science, asked the famous question, can machines think? He reframed it into a practical test. If a human couldn't reliably tell the difference between a machine and a person in conversation, the machine could be said to display intelligent behavior. This became known as the Turing test. Then, in 1997, IBM's Deep Blue defeated Garry Kasparov. This is significant because IBM's Deep Blue beat the world chess champion. This proved that narrow AI systems could surpass humans in highly structured tasks. Then, in 2012, the ImageNet breakthrough took place. This is where deep learning dramatically reduced error rates in image recognition competitions. This was a turning point, showing that neural networks could achieve high performance when paired with massive datasets and modern GPUs. And then in 2016, AlphaGo defeats Lee Sedol in Go. This was historic because Go has an unimaginably large search space compared to chess. AlphaGo combined deep learning, reinforcement learning, and Monte Carlo search to play in ways that seemed intuitive, even creative, and beat one of the best players in the world. Then, in 2017, came Transformers. The paper, Attention is All You Need, introduced the transformer architecture, revolutionizing natural language processing. This innovation paved the way for today's large language models. And then in the 2020s came generative AI, large pre-trained models that now generate text, images, and even code at scale. Generative AI has moved into mainstream use, transforming business, education, and everyday life. Together, these milestones chart the path from early theory to the AI systems we interact with today. So, how does machine learning work? At a high level, machine learning follows a loop where it collects data, trains a model on it, evaluates performance, deploys to production, and then monitors results. The goal is to generalize from past patterns to new data. Success depends on good data, the right features or representations, sufficient compute, and solid evaluation metrics. All right. So AI is powerful because it can analyze huge amounts of data, spot patterns we'd miss, automate repetitive work, and even generate new content like text, images, or code. But AI also has limitations. Models can reflect biases in the data they were trained on. They can hallucinate, producing confident but factually incorrect answers. They can also struggle when faced with situations very different from their training data. This is what we call out of distribution failure. For example, an image model trained only on sunny daytime photos may misclassify objects in a snowy night scene. And finally, today's AI often requires significant computing power to train and operate. Because of these limits, the best practice is to keep a human in the loop, providing oversight, review, and governance to ensure AI outputs are accurate, fair, and trustworthy. And now we'll discuss a few core terms. A model is a learned function, mapping inputs to outputs. Training is adjusting model parameters to reduce error. Inference is using a trained model to make predictions on new inputs. And parameters are the internal values the system learns. All right. So this marks the end of this lecture, and here are some of the key takeaways. So AI is the broad science of creating intelligent behavior. Machine learning is AI that learns patterns from data. Deep learning is machine learning built on multi-layer neural networks to tackle complex problems. And generative AI is the capability to create new content like text, images, or code, most often powered by deep learning today.